Hello everyone! Today we will cover an exciting topic, AI in private cloud, and we'll catch up on why should you bother and what are the advantages and disadvantages of such a solution. I'm not alone today, I have a very special guest, one of my colleagues actually, an OpenStack specialist, our product manager, Titus. I will not try to pronounce your last name, sorry. Um, and before we dive deeper into the topic, I will say that it's really AI is everywhere nowadays. We have use cases all over the world in all industries, and the truth is that everyone talks about it. Well, we also have to look on how do we make it happen, and that's where the challenges come in place. That's where the questions often appear. Data scientists, machine learning engineers, they just start on a laptop often using Ubuntu as their main operating system. But as they scale and the expectations on their projects grow, they look for changing the infrastructure, for upgrading it actually to get more compute power, to have platforms that enable them to collaborate with their coworkers, to be able to serve models to edge devices. But today we'll focus on the middle part, which is really related to the infrastructure to build reliable and repeatable projects and to scale your initiatives. And in case you're wondering why on premises, it's no, for me, it's easy, but there are no doubts actually that more than 60% of respondents from the AI Infrastructure Alliance report that was done almost 2 years ago confirmed that they actually use built in-house clouds for either all their AI projects or for part of them. And I'm curious, or I hope that we'll also cover a bit on hybrid cloud status. Now I'm giving some ideas on what will happen. And for now, the stage is yours. I see you start with the public clouds. I thought we agreed we are going to talk about private ones.
That's what we agreed on, indeed. And thanks for introducing me, Andrea. My second name is Kurek, by the way. I'm not sure I'm an OpenStack expert. Like, this is a very big project, so getting an expert in it can take you years. But in this very short pitch, we'll try to set the ground so that you can actually, tame this beast, right? Like, it is possible to tame this beast. So, yeah, we start with public clouds because this is where the journey usually starts, right? Like, public clouds are this amazing class of infrastructure where, getting started feels like pushing a button, right? So this is why you can see this big button here, and a lot of organizations actually start their journey with the cloud exactly there, right? Like, public clouds provide you with these amazing capabilities so that you get an immediate access to all of those, almost infinite, highly scalable resources, right? And this includes virtual machines, but it goes way beyond virtual machines. This includes storage, this includes containers, this includes everything, right? Like, at the end of the day, all you need to do is to create an account, attach your credit card to the billing system, and then you can start using the cloud, right? So that's great. And we fully recognize that. And well, as this is where the journey usually starts, like, no surprise, we are working with all the leading public cloud providers, right? But at the same time, sometimes it makes more sense to run AI in a private cloud, right? So here the situation is a little bit different, right? Like, it does not feel like a push button type of an experience. And you're exactly right. It does not feel like that. And there's a number of questions and concerns and doubts that you might have when it comes to running, not just AI workloads, but any other types of workloads in a private cloud, right? Because to run workloads in a private cloud, first you have to build it, right? And that's not a trivial process. Well, it starts with, careful design, hardware selection. Then you have to purchase all of this hardware. You have to ship it to your office. Well, you have to find a space where you want to run your private cloud. Like, do you have a space to run? Do you have a data center, right? Like, do you have enough power? Do you have, you know, air conditioning and cooling facilities to be able to run your own data center? Then You have to unbox all of those servers. You have to put them in a rack. You have to cable them, enable networking. Uh, then you have to install the operating system there. Then you have to install the cloud management software over there. And you finally get a cloud. But then you discover it's just the beginning of the journey, right? Like it goes way beyond that because this environment has to be operated on a daily basis, right? So it comes with another number of challenges. You have to deal with things like updates or upgrades, and you have to deal with backups of this environment. You have to deal with ongoing security maintenance. So it is a complex process, right? Like, and no one's saying it's trivial, but sometimes it's needed. But why is it needed? So you might be wondering now, why is private cloud relevant in the era of hyperscaler? So if all of those public clouds give you with these amazing capabilities so that you push the button and you're done, why do you need a private cloud at all? So there are multiple reasons, and we'll try to cover them one by one. So for all of you who've been using public cloud, you've probably familiar with you're already familiar with some of those. But if you're still like in the middle of cloud migration, you might discover them sooner rather than later. This is how it usually happens, right? So the first biggest challenge with public clouds is the TCO, the total cost of ownership. So the way costs shape in public clouds is that if you're running a small workload, like if it's just a single VM, and it is not a VM that has significant resource requirements, then it costs relatively low, right? Like it's something that a small business or like even individuals can afford. However, if it's an AI workload that usually consists of hundreds or thousands of containers that consume like a lot of CPU cycles, because those are compute intensive workloads, right? Like they consume some RAM, they consume some storage, because at the end of the day, right, like you rely on the data that you have to use to train your models and so on, then these costs can grow significantly, right? So it all depends on the scale, and it all depends on for how long do you actually run your workloads, right? Like at some point, you'll just discover it makes more sense to build your own environment um, and optimize costs that way, right? Like owning is just more economical than renting in a long term and at a scale, right? So everything depends on the scale and everything depends on the timeline, right? Sometimes it makes more sense to run your workloads in a public cloud. Sometimes it makes more sense to run them in a private cloud, right? Like it all depends on what your workload is. But moving back, on the other challenges, digital sovereignty is another significant challenge, right? So in some parts of the world, especially this is especially relevant for governance and governance institutions. Like they find out that relying on public cloud providers is a huge risk, because at the end of the day, those are external companies, right? Like, and it's not even just about the security. It's not about a risk of a data leakage or whatever. It's just this lack of trust in those companies, right? Like if you're storing critical data in a cloud, like military information, for example, or citizens' personal information, right? Like this creates a huge risk if you rely on an external company, right? So uh, there is a move around the world to kind of start safeguarding the data, and a lot of organizations find themselves in a need to build their own cloud, like a kind of a sovereign cloud, uh, where they can take a full control of their workloads and their data. And last but not least, performance. So as I said, right, like AI workloads are usually compute intensive, so you might be willing to optimize your underlying infrastructure for this type of a workload to make sure that you do not face any bottlenecks, right? And here again, in some cases, it might make more sense to build your own cloud, right? So we're all in favor in starting in public clouds, but at the end of the day, at some point, it makes more sense to move on-prem. And now moving on, what we propose is that whenever there is a need for running your AI workloads on-prem, you build a private cloud that not as a replacement to the existing public cloud infrastructure. Like we would never recommend, swapping AWS or Azure or Google for your own cloud, but rather building it as a kind of an extension to the existing public cloud infrastructure and plugging it in to your existing ecosystem. The good thing is that as Canonical, as the company behind Ubuntu, we work with all leading public cloud providers to ensure that you get exactly the same experience with Ubuntu as an operating system across like all of these kinds of environments.
Titus, I'm sorry to interrupt you here, but there is a question that comes up to my mind. In the AI space nowadays, often organizations look at hybrid clouds in order to run their workloads. They begin on a public cloud due to ease of access or accessibility to the cloud computing, but then they often scale on-prem. Is it something that we can offer or we can capture with this kind of setup?
This is exactly what we're proposing, right? So by building your own cloud and kind of plugging it into the existing, public cloud ecosystem, you can actually build a hybrid multi-cloud, right? Like, and what we like, if we go to the next slide, what you can see is that this actually becomes a trend, right? So taking a look at the Global Hybrid Cloud Trends report by Cisco from 2022. 82% of IT decision makers have already adopted the hybrid cloud strategy. So there's no reason why you should not be the next one, right? And now taking a little bit closer look how this could look like. So we set what we propose is a hybrid multi-cloud setup, right? So you have a public cloud or more than one, right? You can have more than one public cloud. Then you have a private cloud that runs on your premises or like in a colo space or whatever. Then we've already discussed that you can put Canonical Ubuntu as an operating system across like all of these types of environments to get the same user experience regardless of the underlying substrate, regardless of the underlying cloud. And obviously for any kind of cloud native workloads, you need Kubernetes, because Kubernetes is this kind of an engine that provides you with container coordination capabilities. So it is a de facto standard for running containers and for running cloud native workloads these days. And given that Canonical MLOps framework that Andrea is going to talk about a little bit later in this webinar, is a fully cloud native workload, so needs Kubernetes underneath, right? But there is one more piece of the puzzle that's very important here, which is Canonical Juju, which is Canonical's product that basically enables fully automated provisioning and, more importantly, ongoing operations for various types of cloud native workloads, right? So Canonical Juju runs on top of Kubernetes as well as any other substrate. But contrary to solutions like Helm, for example, it does not just help with the initial delivery of a cloud native application, but also with its ongoing operations. So by using the concept of operators or charms, which are kind of software extensions that contain a distilled operations code for applications, you can spin up a Canonical MLOps platform on top of Kubernetes, on top of any cloud, right? That more importantly, you can also operate it post deployment.
If I add, Titus, two things here. Sorry to interrupt. On one hand, it's important to mention that on one hand, our solution runs on our Kubernetes, but it also runs on any other Kubernetes. If it's EKS or EKS that you already have in place and it's CNCF conformant, there is nothing to stop you to build on top and to choose on top an open source solution, exactly for the hybrid cloud strategy that we already mentioned about. And also, we don't capture it here because we focus on the infra side, but also using part of the image that you have here, you can end up deploying your models to edge devices. And maybe we'll go in details with this topic a bit later in the year, I would say. Back to you, Titus. Apologies.
No worries. I think that was very important point to take, and this is also the reason why I have like an upstream Kubernetes logo here, right? Like just to demonstrate that it is any CNCF conformant Kubernetes, and we would always encourage you to use the one that makes more sense. Like in public clouds, this might be the one that is delivered natively by the public cloud provider, right? Uh, so moving on. You might be now wondering, like, what is this private cloud? How does it actually look like underneath? Because we've been talking about it for a while, but haven't really started uncovering it, right? Like, I only said, like, it is likely a little bit complex beast that consists, of some physical servers. We said they have to be racked and cabled. We need operating system there. Then we start, putting the cloud management software. But how does it look like underneath, right? So let's start uncovering that. So if we go to the next slide, exactly here, this is how it looks like today. And I think it's important to mention that this stack continues to evolve, right? Why? Because, well, our goal is to pick up the best of breed technologies that are currently available on the market, right? We as a company behind Ubuntu, the world's leading Linux distribution, we take a holistic view at the entire spectrum of open source, right? And we pick up the open source projects that make most sense for the current market needs, right? So as of today, this stack consists of those technologies that are listed there, right? Like we use Mass for bare metal provisioning to automate everything related to bare metal. Then we use OpenStack to provide infrastructure as a service capabilities. Then we run Kubernetes on top of OpenStack to provide container coordination capabilities, basically CAS experience, container as a service. And we use Juju on the top that was mentioned previously, right? The good thing with this stack is that it provides all types of workloads, basically, right? Starting from bare metal through virtual machines up to containers, so you can get like all types of workloads supported under a single platform. But even more importantly, from like a business point of view, is that all of this software, even including guests, is covered with a single subscription, right? So that's called Ubuntu Pro. We likely will get into that in further parts of this webinar, but it's basically like an subscription for all of the open source goodness that provides you with extended security coverage and support for various open source pieces. And importantly, it is charged per node, so enabling fully transparent budgeting and predictable budgeting. So digging a little bit more into that, you might be wondering now, how is this Kubernetes and OpenStack story shaping together, right? Because we said, like we use the best of breed technologies, and this is why OpenStack is there in the picture, for example. You could run Kubernetes directly on bare metal and just eliminate OpenStack from the picture. It's totally fine. It's just, like to get a full experience, it needs to be there, right? Because otherwise you're losing, traditional infrastructure as a service capabilities provided by OpenStack. A good thing is that you can run Kubernetes on top of OpenStack in an on-demand way, right? So whenever it's needed, you can just simply provision Kubernetes clusters on top. And for this purpose, you can use either Canonical Juju. Again, I said Canonical Juju works on top of Kubernetes, but can also work on top of other substrates to provide applications like on top of OpenStack or public clouds. So it can also be used to provision like a fully functional Kubernetes clusters. But at the same time, you can use the OpenStack Magnum service that is, connected to, like, it's plugged into the OpenStack control plane APIs in a nice way. It's basically the same APIs as upstream uses. Um, the only drawback as of today would be that the guest images would be provisioned with a Fedora operating system. We're working uh, on enabling like a fully native Ubuntu experience. It is work in progress. Will become available soon. So I would encourage you to watch our release notes to see when this story is fully baked in. Um, and finally, getting back to the performance story, so it is really important to mention that we really, our goal is to help you come up with a highly performant infrastructure without putting an extra pressure on your budget, right? So we want you to be able to get 100% from your hardware, right? Like, and the platform that we're putting in front of your eyes, has all of the EPA features enabled. So this includes things like CPU pinning, SRAOV, huge pages, and these kind of things. We also work with NVIDIA on the GPU virtualization technology. So GPU virtualization is fully enabled in the platform. It enables you to slice GPU devices and allocate like these kind of virtual vGPU devices to virtual machines running on the cloud, and then pass them to your containers and your AI workloads. And finally, we work with NVIDIA and other vendors to provide uh, to enable hardware offloading capabilities with DPUs or smart NICs to basically free up the CPU cycles on a hypervisor so that they can be fully allocated to your AI workloads that, as said many times, are compute intensive. So taking a look at this diagram on the right, like what you can clearly see here is like a kind of a triangle of CPUs, GPUs, and DPUs. Um, this is likely how the future of the data center is going to look like, right? So we stay at the forefront of the technology. We make sure that all of those, devices are natively enabled in the platform, and that you can take, 100% use of them. And on that note, I'm going to give the floor back to Andrea, who's going to walk us through the MLOps platform that we have.
Thank you, Titus, and thank you a lot for all the information about the private cloud. Now I'll try to put them in context even more on the AI space, and I will start with MLOps, or machine learning operations. And for those who are not familiar with it, I always define it as shortly DevOps, but for machine learning. And it's in fact a practice that aims to enable reproducibility and collaboration across large teams when it comes to machine learning projects. And why this is important, you might wonder. And the answer is simple. When we look at AI projects and the need to scale them, that's when private clouds and all the information that Titus described is relevant, because you end up having large teams that are looking for different projects. You end up having multiple projects, which is again important because maybe you don't want your financial data to be accessed by all the data scientists within your organization, but maybe just some of them. And last but not least, you have a need to automate part of your activities, because otherwise it becomes a burden. What we did not mention yet is also the importance of building a long term, or maybe long term is not the right word, but a reliable model, because you don't deploy it once and you never look at it again, but you need to be able to redeploy, retrain, monitor in case something fails. Because if you, I don't know, imagine you have a surveillance camera that has a machine learning model that alerts the authorities in case of an accident. You don't want that to sound and to call the police always when it's not needed. And for that, you always need to ensure that it is up to date, it is retrained, it is maintained in case something fails, such that the day-to-day life is not affected. And AI doesn't become a burden, but rather a help in our lives. And building a private cloud for AI is not only about a platform or a product. Sorry, it's more about a suite of products that go hand in hand together in order to cover the machine learning lifecycle. And the truth is that often the machine learning lifecycle on its own is overwhelming for professionals because it seems long, it seems complicated, and it includes very different activities. If you look at the data stage, on one hand, you need to store your data, of course, and that's why you see in this picture a lot of databases of different types. But then you need to stream your data, you need to visualize your data, and only after that, we move towards the machine learning part, the MLOps part, where you develop models, you train models, you experiment, you store features. And once you're happy with your with this part, and you've got the winning machine learning model, you move towards the edge and to the model serving part, where you again need another suite of tools. You need monitoring capabilities, you need data drift capabilities, such that this entire life cycle stays always up to date and relevant. As you might guess, it needs a lot of compute power, but it also needs enough capabilities that go beyond that, and Titus described them very well, um, to make them happen. On our side, we do have a seamless integrations between these tools, and when in a world where there is a new tool popping up every other day, having a cohesive solution that enables you to do all these activities that I just described one to in one tool and in with the same experience, it's really powerful and actually needed. But also you have the composability side, because unlike maybe other areas of the technology where you would have an almost out of the box solution, AI is not like that. It really depends on your use case. It depends on how you collect your data, what kind of data you use, what are your requirements. For example, do you need real-time processing or not? And based on it, on this, you might need different capabilities, different tools, like, and that's why you see there similar solutions like Seldon and Kser are a good example. They seem doing the same thing, but the truth is that they don't. So when it comes to why using on-prem, I had the same question at some point. I had a fun chat with Titus about it. And I always said, especially if you already have existing infrastructure in place, there is no reason not to use it. And here it's interesting to actually be open-minded and not use it just to scale your AI workloads, but maybe you can even experiment there, because there are tons of studies on the market on how GPUs are underutilized, on how they stay there and we don't use them enough. So if there is already a private cloud with existing infrastructure, look at the possibilities to leverage them the most and use capabilities such as the offloading ones that Titus just mentioned in order to get the most out of them. You don't need to always train models, for example, at the same time as you don't always need to deploy models. So having a strategy based on the existing infrastructure, I think is it helps in the long run. And Titus already also mentioned about the public sector organizations and the industry regulations. And I think when it comes to machine learning projects, this becomes even stronger. The main reason for that is that data is the heart of any project. And at the same time, data is a very sensitive topic. Organizations, actually beyond public sector organizations, healthcare research institutes, financial services organizations, they store very sensitive data that cannot and should not be given to the world. And that's why they often look for extremely secure environments and also ownership and privacy of the data. It goes even beyond the existing regulations on the market. It goes to their need to ensure that their almost strongest asset is not put at risk, or that their trust and credibility on the market is not put at risk as well. Um, I already touched upon the modularity of the solution, and I strongly encourage everyone to look at their use case, look at their needs, and based on it to build a solution and to choose a solution that fits their needs. It should not be what your competitor does. It should not be what you read on the internet, but rather what fits you the most based on your needs, your use cases. Always start with the use cases and then drill down to how it looks like. And this goes hand in hand with the long term vision because whereas getting started is always exciting, any new projects and any innovation is fun, but the truth is that we need to look at it in the long run. And especially if you start on public clouds or just on prem, look at the long term vision. Will you want to build a hybrid cloud now or later? Do you want to have a multi cloud scenario such that you protect parts of your data? Do you think you'll go through many merge and acquisition um, projects in the near future such that data is likely to be on different clouds and again you need a different setup? All these kind of questions are going to help you build an architecture that includes likely the private cloud but is also suitable for your organization. And Titus, I think you've been quiet for too long, because I'm about to challenge you a bit. We already covered a lot of the reasons why you should choose a private cloud. Security and compliance are the no-brainer ones for me. They're strong reasons why often enterprises choose them. But at the same time, I often hear organizations saying, Andrea, this is too expensive to get started with. What do I do now? I'm sorry, I don't want this. Titus, how often do you hear that?
I think we hear it quite often. The first thing to say, and I think it's really important for the audience to understand, is that we would never push you to move to a private cloud until we both agree it makes sense for you, right? This is why we started the whole journey with public clouds, right? Like, and again, right? Like, if a public cloud is the best place to run your workloads, this is where you should start, right? Like, there's no reason to, pull the teeth here, right? But at some point, right, like once we both conclude so that the private cloud is a better space, this is where it should be, right? Like, and let's just try to address that, right? So taking a look, first of all, I all agree with the thumbs up here, and I agree with the thumbs down as well, but there is a way to tackle that, right? So taking a look at this list, so uh, initial investment, I fully agree with that, right? Like, and we want to make it clear, like building your own cloud comes with an investment. Like, you have to purchase the hardware, you have to power the hardware, you have to put the networking equipment over there, you have to deliver it, you have to operate it. There will be a cost for sure, right? Um, One thing we can help with that is to provide you with a price performance optimized architecture for your cloud build, right? So what we can provide is like a reference hardware document with bombs from leading IHVs that will help you to build a cloud that would be highly performant, but at the same time put not much pressure on your budget. In terms of hardware shipment, that's a similar story, right? So we work with leading IHVs, and you can get bombs that are now available on the market and get them delivered. When it comes to post-deployment operations, there are two ways we can help. So first of all, it all ties back to the automation framework that we are talking about with Mass and Juju, providing providing you with a total bottom-up automation for your private cloud, including uh, physical machines provisioning up to automating very complex, historically complex operations such as OpenStack upgrades, for example, right? Um, an over provisioning risk, there's always a risk, but we would always encourage you to start small and grow at your own pace. And when it comes to limited elasticity, uh, this is a similar story to the post deployment operations, right? So with having the right automation framework in your hands allows you to scale out relatively quickly, and treat it as just yet another operation in a cloud that you would run typically. Does that answer your concerns, Andrea?
It does answer my concerns, and I would actually be curious if people who are watching us have other concerns that we could address, because these are the ones that I have, but of course I have a biased opinion since I keep moving around the AI space. But thank you, Titus. Let's see what we hear from the audience in terms of other concerns. And I think you captured them correctly. I would also like to add or to highlight even more that for me, and probably it goes actually hand in hand with my next slide, for me, when it comes to AI projects, this is the way to go to build a hybrid cloud strategy. I don't think you should run and clutter your private cloud with all the projects that you have because then because you pay actually less, you might not be that mindful on how do you use it. At the same time, experimenting on a public cloud gives you the ability to quickly play, to quickly spin up a notebook, to quickly get some intermediary results to validate an idea or a project. And but running in production, I always think it should be on a private cloud, so a hybrid cloud strategy that and tools that enable you to have the same experience, a consistent experience, and the same skills. Maybe we don't talk enough about it, but if there is something that the AI space doesn't have, it's enough specialized people. So expecting to find someone who knows very well, for example, a cloud native MLOps platform and another platform for on-prem deployments is very difficult. But if you as an organization can give them the almost the advantage or the benefit to use the same um, platform, you're going to upskill people much faster. Um, so that's well the long-term vision. I think it is. That's what we see from the market as well. And the report that you shared, Titus, on cloud is not just on cloud. There are plenty of reports on how the long-term strategy for AI projects, digital transformation, and so on goes on hybrid cloud. And the truth is that maybe it's obvious, but or maybe not. But the truth is that you can have on-prem AI projects literally in any industry, and it goes back to the fact that AI is everywhere. It's from healthcare to retail, from logistics to automotive, and there is no reason or blocker for you as an organization or as a department to consider it. I'm not saying you have to buy it or you have to go for on-prem deployment, but regardless of the industry, you should consider it. Uh, and make a clear assessment on where you stand now, as well as what's your long-term strategy. And once you end up having projects in production, probably the next step and the next natural step will be to optimize your operations. Platforms or MLOps platforms that can run the entire machine learning lifecycle are exciting, but also the ability to scale your AI clusters or to get high performance networks are features that are going to to pay or to make a bit of a difference, uh, and you're going to look at. So looking at them early on and the possibilities or opportunities becomes important. Now, when we look at Canonical in the AI space, I think by now you might have an idea. We talked a lot about the infrastructure layer. We focus now only on the private cloud with Canonical OpenStack, but it goes beyond it with Canonical Kubernetes, for example, Ceph for storage, Maz for bare metal. So it really depends on your needs. I go back to it. And then we also have our Canonical MLOps solution, which is a plug-in, plug-out architecture that enables organizations to run their entire machine learning lifecycle. If there is one thing that I often hear is, Andrea, we want to get started with AI and we don't know how. And that's why we have AI consultancy services that address different layers or different needs of organizations, from data exploration workshops that are just helping enterprises get started to actual MLOps workshops where we help you design your architecture. We have them all, and it really depends on where you are in your AI journey. And with this, also being conscious of time, I'm getting close to an end. And my usual advice to anyone who looks at machine learning nowadays is to get started with a use case. Don't do it because it's cool. Don't do it because your competitor does it. Don't do it because you watched this webinar. Do it because you really have a use case. You have a business problem that you're trying to solve. And whereas the journey might seem a bit longer, scaling on premises makes sense for different reasons that we already talked about. And then considering open source tools gives consistent experiences as well as performance across different layers of the solution. Titus, is there anything that you would like to add?
I think you've nailed it, Andrea. I think this is how the journey should look like indeed. So don't forget about the hybrid multi-cloud strategy. It is really how you should shape, the way you do infrastructure in your organization. Start with a public cloud, move to the move on-prem when it makes more sense. We can definitely help you on that journey.
Thank you. Now let's see if we have some questions, Titus, and maybe some more concerns that I'm sure you can address.
Happy to address them.